Okay, so today I'm going to introduce the conditional expectation function. I'm just going to abbreviate it, conditional expectation function. The name really is a pretty good description of what it is, but before leaning into that, so up until this point what we've been discussing has been basically using expectations operators to calculate some sort of distributional information. So that's been our primary focus up until now. Recall too, we had just the simple expectation operator of x. You can do the same thing with the expectation of y. So we could take a large just pool of output information and aggregate it and then take essentially just an average of it, because that's what an expectation operator is. It's just an averaging machine. So the conditional expectation function is building on this idea. Because the mean of the y's doesn't tell us much, so it doesn't convey much information for us, what we end up wanting to do with this is actually say, okay, we want the expectation of y, vertical bar means given some value of x. And so again, you could think of x as a categorical value. So last time we had 1, 1, 2, 2, 2, 2, and 2. So when we say y given x, it's given just the value of those x's. But what's interesting is these x's might have various outputs. So you might input, one individual might input 1 and then yield, say, 2 output. One might have an input of 1 and yield 20. I don't know. Just using that as an example. Again, you can think of this as a functional relationship. So y equals some constant times x potentially, but that also varies from individual to individual. So the constant has subscript I and x has subscript I. Hopefully I haven't kind of buried you too far yet in confusion. That's not my intent here. But I do feel that this will become clearer if I provide you an example. So suppose we have x, and that's education. So we're counting this as years of education. We have multiple rows, one where you've got 12 years of education, 13, 14, and 15. Then over here, we have all y, which will stand in for wages. So this is incomes. So we would think, okay, yeah, maybe there's some sort of functional relationship between the amount of education that I have and how much money I make. Presumably that's why you're in school now, and why you're taking econ as opposed to, art. Apologies to those of you that are minoring in econ and majoring in art. That'd be an odd combo. Although not actually as strange as you'd think. I actually did want to do my parents helped pay for college, and I did want to do theater as my minor. And they said, absolutely not, no way, unless you want to scrap together every last dime. And I wasn't, I didn't hate myself that much or love theater that much. So I was like, okay, fine, we won't do that. So all wage, and these are observations. So I'm going to abbreviate. So it's all y observations. We'll get into that in a second, why this will make sense. And then we have a column called the mean of y's. So within these so we have various observations. We're going to have various individuals here. That's what this is telling us. And so we're going to have 36,000, and I'm just going to, again, shorthand this, so it'll be 36 for 36,000, 45 for 45,000, and 51 for 51,000. Now, when we say the x value is 12, but we have 3 observations of y's, what does this mean? Well, it's just like that idea. Suppose instead of those 1s that we had from last time, those are now 12s. So the x's are now 12s. But these are each different individuals. So I, 1, 2, 3. Individual 1, 2, and 3. The y's now take on these various values associated with those different individuals. So we have one making 36, one making 45, and one making 51. That's all that's being said here. I'm just shorthanding it in this for space. But that's what we're saying is now the value or the input value of 12 is yielding different output values. So that's the sort of the interesting addition. It's now no longer just saying, because before we were just saying focus on the axis. So in this case we'd be like, okay, well, out of our total pool here, we observed 12 3 times, and then so on and so forth, just like last time we had said, well, we observe 1 2 times, 2 5 times, and 5 3 times. You can tell how many times how many takes of those videos I've done. I'm not going crazy at all. So then this idea of the means of the y's. This is where this function comes into play. In particular, what this function is telling us to do is it's saying, okay, take the expectation of y given that x equals, now in this case, in this row, x equals 12 years of education. So given that x equals 12, what is our expectation of y? So that's literally still same expectation operator. It's just narrowing it down. So instead of taking all of the y's, which I will list out, it's saying just take these 3 guys that we have in this observation here and average them, or gals. So that ends up becoming an average of 44,000. So if you average these, $36,000 a year, $45,000 a year, $51,000 a year, that becomes $44,000 a year on average between all of them. Now I'm just going to list these out for you, so if you want to play with the numbers at home, you can, which is always good practice. 52. This is going to be the expectation of y, given that x now equals 13. The same thing, nothing crazy here. We're just literally taking the average of all of those y observations. If you want to complete this, if you see how to do it, please do this on your own as well. Pause the video, that sort of thing. Sometimes, even simple math, sometimes it's good just to do things by hand, because then you associate a little bit more of a memory with it, I feel, than if you were just watching me do these. $14 years of education, $46,000 a year on average between our individuals. Now I did this for convenience, that I have 3 individuals per bucket. Obviously in the real world it could be random. Could be part of the study design where they would say, hey, we actually the way we want to structure the study is to have an even number of individual observations per associated x value. That's possible. So it could go either way depending on the study design, but for now I'm just doing that for convenience. 55. Expectation of y, given that x equals 15 years of education, equals $48,000 a year, based on those pieces of information. So why are we doing all of this? So we want to use averages because we care about the category of 12 years, or 13 years, or 14 years. Suppose that this $36,000 a year was Tom, and this $53,000 a year was Ava. Well, if our question, our empirical question is, what effect does education have on wage outcomes for individuals, and we wanted to have some sort of functional association between, if you have this many years of education, what is your expected income? It wouldn't be very useful for us without the attending information of, no, in fact, Tom had 12 years of education and Ava had 14 years of education. And Tom and Ava could be outliers, and so it's useful to say, no, we want a large pool of individuals. I know 3 is not very large, but in reality it maybe it's a few hundred observations or even 1,000 per each of these categories. So if you have, say, 1,000 observations, you're going to smooth out the outliers due to the law of large numbers, and you'll probably get a pretty good sense of, okay, the average pool of those with 12 years of education earns about $44,000 a year. And that's what we're concerned about. We're concerned about education as it relates to income, not Tom as he relates to income. Who knows with Tom, Maybe Tom's just, made poor choices. And so $36,000 a year, Tom doesn't like working all that much. Whereas, Bob over here, same level of education, Bob works hard, makes $51,000 a year. So, big difference between the two of them. But that being said, again, just want to stress that that's what we're focusing on, or why we're focusing on this is we're concerned with category. And so these expectation operators allow us to basically create associated categories. And so if we were to lay these out then, again, this kind of gives us a way to calculate it. Just put it in other terms, we could say that for all the average being, so the average of the X values are essentially fixed. So we're saying that, okay, there's 12 years of education. In that pool, what we're really concerned with is, okay, what's the average wage for all concerned with 12 years of education? That's $44,000 a year. 13 is going to be 45. 14 is going to be 46. 15 is going to be 48. That's the big thing. And then now this would be good practice for you guys, but we then can take this information and we can also build a regression line off of this. So this information, if you guys want to practice this at home, again, good practice, would be y equals 1.3x plus 28.2. Now again, we were calling these k, so whatever output you get, just multiply that by 1,000. I'm not going to get into the weeds too much on this in this video because I really just want to introduce this stuff to you guys right now. But where we're headed with this, and why you're watching my channel and why you're not, presumably wasting time on somebody else's channel that's really glossing over this information, or unfortunately, and this was my experience too in undergrad, it's getting glossed over in lecture. I'm going to start making distinctions of what various errors mean. Because what you're going to find is this particular function, the conditional expectation function, does not equal this. It does not equal this in terms of the outputs. That is to say that our regression line is the line of best fit. But if you plug in 12 into the X here, you're going to get $43,800 a year, not $44,000 a year. And so I want to draw that distinction now so that you guys are aware of it as we move forward. For now, I'm going to leave you with that to stew. The biggest thing I really wanted to focus on again was predominantly just the use of this particular expectation operation itself, because it's allowing us these associated points that we then can build off of and work with. But for now, I'm going to leave it here. If you found this video useful, like, comment, subscribe, please. I do appreciate that, and we will pick up where we left off next time. So thank you.